Okay, so I'm Ezio Melotti, he's Franco Carbognani, and we are two members of the Italian Mars Society, and we are going to present this talk called Python on Mars. Do you have the microphone? Okay. Okay.
Yeah.
Particular quote.
So thanks for coming, and yeah, as said, we belong to the Italian Mars Society. That is a chapter of the Mars Society advocacy organization that is worldwide. So let's start with some prediction from the previous centuries. These are predictions from the 19th century. As you can see, I don't know, they were talking about rail travel and quite interesting prediction. Same kind of prediction for the 20th century. For what concerns aviation, you see, they speak by themselves. And also some 21st prediction. I don't know, in 2006, estimation that traveling to Mars would be, again, putting your brain in big danger, or statement like that, that is virtually impossible. So in my opinion, as you can definitely laugh about the prediction we saw before from previous century, in my opinion, in 100 years from now, there will be a place like this one in which people will be laughing on prediction that has been done, that are done at the beginning of this century. So instead of just, again, making those kind of useless prediction, I think it's useful to look at the reality, to look at a real problem, having, let's say, an engineering approach to what are the so-called Mars showstoppers, so that are the threat on human health and safety that can really make a mission to Mars impossible. So these are the so-called 5 showstoppers: hypogravity, radiation, and obviously need for regenerative and bioregenerative life support. I mean, to make you living during the travel and on Mars itself. Also, Mars dust. It's definitely a problem that need to be managed. And last, you need to assure that you are not creating problem while you are going to Mars, especially because you want to study if life is already there, and also, I mean, don't get contaminated with whatever is there on Mars, if possibly some life is there. So.
Okay. So yeah, I can tell you something more a bit. So hypogravity, as you might know, like Mars is more or less half of the size of Earth, so it's quite small. The gravity is also smaller. We have like 30% more or less of gravity in here. So hypogravity, it might cause problems, because if we have a mission on Mars, people will stay there with a different gravity that we have on Earth. So we are not adapted, their muscles will suffer this, and we are not evolved to live with this kind of gravity. So this is the first problem. Then we also have radiation. This is something that will affect both the travel to Mars and also the life on Mars, because the atmosphere on Mars is like thinner than on Earth. It won't protect you from all the radiation that you get from the sun. So if you go and live on Mars, you need to protect yourself from the radiation. Then, like I guess all of you like to breathe, eat and drink, and if you go to Mars you probably want to continue do this, and to do that you need to figure out something. So you need some way to get the air, the food, and something to drink, and you can do this by recycling as much as you can, but also like by producing things. You can have greenhouses and grow some vegetables. And the other problem is Mars dust. This is an actual image from the Opportunity, and it shows like a Mars dust storm. And dust on Mars is actually a problem, because it might affect both the machinery. So the dust can get in, especially into mechanical parts. It can consume all the machineries. and also it might be dangerous for humans because there are like fine dust that if you breathe this dust, if it gets inside the habitat, inside the station, you might breathe it and it might be dangerous for you. And as he was saying, like the planetary protection, both ways, because you don't want to bring anything there and you don't want to bring anything back. If you saw this movie, the plot was something like some alien forms get on Earth and then starts killing everybody. That's probably not likely, but you get the idea. Okay, so.
Yeah, obviously to study the problem, so those showstoppers, you need some way to do it, and the best way to do it are analogs. So you would like to have analogs of the same Martian condition you will find here on Earth that allow you to study the problem and to find technical solutions for those problems. So there are already many, let's say, analog stations here on Earth, but they have some limitation. They tend to stay on extreme environment, and in this way trying to simulate as much as possible the condition you will find on Mars. But there are obviously limitations on that. So for example, for what concerns shielding, normally you have this station that are like classical tuna can, and till now, I mean, not big effort has been made in shielding, also because again, shielding those tuna can is not always easy. Sealing is again something that is not yet done very well. Those structures are normally not sealed, and in this way try to simulate a complete closed life cycle become difficult, and again not talking about dust control that at this point become practically impossible. For what concerns the location, at the end of the story, I mean, supporting those stations in extreme environment become in itself such a problem that typically they tend to not to do simulation implying very advanced technology, because at the end this becomes too difficult to be supported and maintained remotely. They can use for very short times, typically during, I mean, the best, let's say, the best season, and also they become at this point very expensive per man hour. And in many cases the logistic cost become the measure cost to run them.
Yeah, and as an example, I was staying at this station here for 2 weeks, and you see, yeah, the Mars Desert Research Station in Utah, and you can see how well it's sealed. We got like mice coming in, and I was feeding them, taking picture of them. So this show that it's not just like keeping dust out, but even like mice were coming in, so it's not really sealed that well.
At this point, also after the experience I had myself at MDRS in Utah, here within the Italian Mars Society, we started to come out with the idea of having something alternative to this, let's say, remote place station. So we started to study in which way you could overcome some of the limitation of the existing station. One of we came out with this idea of the European Mars station, in which we would really focus on the points that are now not very well studied in the existing station. So for example, for habitat shielding, we would like to have a station in which the new ideas like this membrane water wall concept will be used. Basically the idea is that the habitat will be an inflatable habitat, and then you can add those membranes on top of it, and those membranes can provide you many things at the same time. They can provide you shielding against radiation, that will be basically the water and polymer. And at the same time, you can also grow things like spirulina algae inside the water that is inside. So basically, these things will provide you both radiation shielding and be part of the bioregenerative system of your station. The other innovation are for what concerns the sealing. The idea is really having this station completely sealed so that all the technology that are needed, for example, airlocks, will be very well studied against the dust, for example. And also for the location, I mean, if you put the station somewhere, I don't know, in Milan or near Florence, at this point logistical costs are very limited. The facility could be used all the time, and they can be supported by an engineering crew, I mean, nearby. And also advanced technology like photovoltaic power generation can be studied. And at this point, the basic idea is that the habitat would be placed inside, for example, a big hangar, and inside this big hangar, for example, you can simulate a Martian dust storm. Just to tell you, there is an institute, a research institute in Denmark. They are producing the equivalent of a Martian dust. So they know the chemical composition and they can produce dust for you. The idea is that you can take this dust, you put it into an hangar, and you create an artificial Martian dust storm, and you study the way your habitat is really behaving in such condition. In extreme environment like northern Canada or Antarctica, you cannot do this, or you could do it, but it would make very little sense. Instead, you could do it in the yard of your home by using a simple hangar in which you can replicate some of the conditions you would have on Mars. Then, again, you can go. Next point.
Non abbiamo molto tempo, vai spedito.
Go.
No?
So, yeah.
Okay.
For what concerns the typology, we are thinking of using an inflatable structure instead of, let's say, hard shell module. And the main advantage is that you would have a larger volume, lower mass, and in this way your crew productivity would be enhanced. Okay. And also, quite surprising, I mean, your habitat would be even more reliable and easy to repair instead of hard shell. And this is, I mean, the first early design that we are doing, in which these modules here are inflatable module. Yeah, go. So for what concerns the project objective, you see, provide in-field assessment of hybrid inflatable habitat technology. Again, it would be one of the first time this kind of technology would be tried, at least on analog on Earth. There are a few other examples on Antarctica, but I mean, not really focused on let's say, Mars analog station. And also the idea is to provide a test bed, an effective test bed for testing the technology that are there to lower the risk of the showstopper we saw before. Yeah, just go on. Yeah, these are, again, the list of the main objective. One of the main objectives is also having something that people can visit and then get enthusiastic about the Mars exploration. Again, having a location nearby on touristic area could also have the advantage that you can bring people in, you can show what you're doing, maybe at the same time like a crew is doing something, explain what you're doing, and what we think is that this could be a very good way of inspiring people and scientists and engineers. Also because I think in this moment in which there is economic crisis and so on, we need engineers, we need scientists to kind of give a boost on the economy, and maybe if you get, say, young generation being enthusiastic about these things, we can also get a boost in economic terms.
We should just say Edward Snowden's there. Let's see how fast we get there.
We are working very hardly in putting together a complete project for what concerns ERAS. We have tried at least a couple of times European application for getting the money, but as you can understand, you need a lot of money and getting them is not so easy. But we are keep trying and understanding in a way, the way we can fund this project. But at the same time, we are trying to implement whatever would be possible with little money, and one of the first natural candidate is the control system. The control system would need just a little hardware to be available and then some software to be developed on top. And this is what we are doing. So this is the first step of ERAS, is exactly its command, control and communication system that would allow, let's say, to provide all data processing, all the monitoring control of the habitat, all the communication and monitoring of the habitat itself and the crew that would be doing EVA, so mission outside the habitat, and also support all data processing and also host the so-called crew mission assistant. And I think doing analog and having a good crew mission assistant, this could be one of the nicest point of the whole system, because you can really understand which would be the best way of supporting an astronaut that is doing an exploration mission using, for example, rovers on robot, and this is what all about. We have started working on this system, and we put the foundation of C3 in terms of a distributed control system. So we, again, classified C3 as a classical, let's say, distributed control system that has this fundamental service: communication, online database, configuration database, and logging. Maybe you can have other like alarming and so on. And normally these distributed control systems are grouped inside frameworks that provide you, let's say, all the basic, let's say, services you need. And the pro of frameworks is the fact that development time can be decreased, maintenance can be facilitated, and you spend your time mainly on developing your own functional part, the real control solution you need, instead of reinventing the wheel. So, yeah, we spent some time in understanding what would be the best framework for us, and we look at this selection criteria. And at the end of the story, we came out with Tango. Tango is currently used mainly for synchrotron, big synchrotron control application. So it has already a large use base and it's been thoroughly tested. And considering this selection criteria, we saw that could fit our need, and we are currently using it and basically our development on top of it. So this is the functional diagram of C3, and I let Ezio go into detail.
Yeah, so this is where Python actually comes in, because these are like some of the things we are planning to do. So we have, for example, communication with PLCs, we have communication with spacesuits, with rovers, with satellites, and actually, yeah, can you hear me from here? Yeah, so I don't need the microphone. Okay, so, and we also have like these space probes, and everything, like every block you see here is like a different server that, and they all talk with each other using this Tango framework. So this framework allows us to write servers for each of these things, and we can do it in Python, and this is what we are doing. It also supports like Java and C++, but clearly we are using Python. And we can make on this server, and we already made some of them. And we also have this crew mission assistant that, maybe can I say that is some kind of AL 9000?
Yeah.
It's like some, it's basically, it makes like, for example, if it sees that there's like some solar activity, so there's like a risk of solar storms, then it makes a prediction. We use like neural networks to make predictions, so we can figure out where there might be a problem, and we warn the astronauts. Or even if the values of the, for example, the earth beats, or the oxygen level, or all these kind of things. So this is what we do here. So yeah, this C3 system will take care of all these things. So it will monitor the habitat, so like the temperature of the habitat, the humidity, if there are leaks somewhere or like some emergency, and not only for the habitat but also for the crew members. So if all the vital signs are good and in like normal range, And it will also allow us to communicate with the several like machinery that we have there, like with the rovers, or even, I don't know, you can imagine like you can regulate the temperature like remotely. If you want to raise the temperature in the greenhouse, you can do it from whenever, or even like controlling the rover. We are actually doing like some project about the rover. I will tell you more about this later. And also communicate with space probes, so we can get data about the environment. So both like satellites, but also like meteorological station. And this is like the AL 9000 I was talking about. It can like make prediction and detects values that are out of range and warn the crew about all these problems. So we already start doing like some real world tests. There was one in Dutch Spain in 2012, and last February we were in Eastbrook. There was like this Morocco field test. So basically there were an actual crew with spacesuits and everything, and all the machinery doing a simulation in the desert of Morocco, because the environment is kind of similar to Mars. And we were in Eastbrook. We were like the mission control on Earth, and we were like communicating with them. So what we did, we were getting data from the Auda X spacesuit. It's like a prototype designed by the Austrian Space Forum. Yeah, and this is what we did. We were like reading data about the Earth rate and the physical activity. So there were like accelerometers on this spacesuit. So we were saying like, okay, now the astronaut is standing still, but this Earth is beating too fast, so maybe there's something wrong with it. Or if it was moving, then it was okay. And we were using neural network. We were just like trying out a bit, like see if it's possible to get the data and make prediction. And we made like some tests, and it was working fine. And also we were getting data from this Unveyor, which is like a space probe that it basically can get data about the temperature, humidity, wind, and these kind of things. And so even here, we were like getting data. We were also using Redis. Also, this is like from an Hungarian team, right? And we were also using Python, so that was like really convenient. We were using Redis, so we were just like reading all the data from the space probe, and we were using them like inside our framework. And this summer we applied as Mars Society for Google Summer of Code, and we are going to work like through the summer on these 4 different projects. So I'm actually one of the students, and my project is about rover control using EEG Neuro headset. So the idea is that since you want to control rovers when you're out into Mars, like on the Mars surface, wearing a spacesuit, you cannot just use a joystick or like maybe drive or control the rover, because we have also like small and big rover. So the idea is like, how can you control the rover and be hand-free? And this is something we are exploring. We have actually 2 projects. There's another student that is looking at the speech recognition. So you can send command to the rover, say like, go there, pick up that stone, dig a hole there. Or what I'm trying to do is see if this is feasible also using like reading brainwaves. So by using thought, you can just push the robot, like tell it where to go, and we want to find out if it's feasible, if it's like accurate enough, and if it will work. We also have other 2 students, and this is a project I started last year when I was at the Mars Desert Research Station. So I was reading data from a satellite, the GOES satellite, about solar energetic proton events. So basically the level of radiation, like the solar activity. And this student is continuing what I started by adding the prediction. So he's also working with technologies that allows you to predict if there's going to be a storm. And this other student is working on the spacesuit, so also what we started in Innsbruck. So making prediction about what the data of the vital signs of the crew members are like, if we are in normal range or if there's some value that is off, and it even predict if something might get wrong. So this is what we are doing, and actually we're like one of the students that even if it didn't manage to get into the program, he just joined for free because it's like really cool projects, and he just join even if he doesn't get paid, and that's great.
Well,
and
I just want to add one thing.
Yeah.
I mean, this solar energetic proton event prediction is something that at the moment is not very reliable in general. This is another example of how technology would develop for exploring Mars would be useful for the Earth. In reality, you should know that, solar storm also generate problem on Earth. Until now, we do not have a good prediction of it. So this is something that is not, we are doing it, obviously, for this project, but our idea is that if we come out with something usable, obviously we will make it available to the community to do real, let's say, solar storm prediction. That is something, again, as I said, there is no good prediction till now, and we are hoping to use, let's say, a machine learning technology to get out something, and if we do, let's say, whatever we put available, we will put everything available on our website and publicize around and say, okay, we do have something reliable, please use it. So you see, again, as in other cases, space exploration technology has always, pushed terrestrial technology, and this is always something we would like to point out.
Okay. And we also have a plan for this summer, but we are not just going to stop after this. We are just start exploring all the possibilities, and our work will continue. We hope to collaborate with, for example, the Austrian Space Forum, because, for example, reading the data from the spacesuit can be done with an embedded computer that stays inside the spacesuit. So it can get the data in immediately and see immediately if there's something wrong. So we were looking at embedded devices, and we hope to collaborate with other space forums and other associations. And also another important thing is that we are doing everything open source, so you can find the code on Bitbucket. You can just make a clone and try it yourself. You can contribute it, you can test it, you can even make patches if you want, or add new server. And we are also using read the docs. We have some basic documentation, because we actually started this project just last week, kind of. Because first we were just experimenting a bit. Now we are making it official. We are making all the main software repositories, start writing documentation, start making more usable for everyone. And we are using all open source solutions and make it all open source.
And by the way, we could say that here we are mixing waterfall classic and agile, in the sense that, as you see, we have template for what concern the software requirement, software design, and so on. So we are trying to mix the two techniques. And also we have a big weekly, let's say, report that are similar to having milestone every 2 weeks in which people are saying what they are doing. So we are trying, obviously, to use a mixed technology, mixed methodology, also because the team is really spread all over the world, in India, Germany, United States, and Italy and Finland, indeed.
Yeah. Okay, so this is a few of the libraries that you're using. As I said, everything is in Python, and we use Pytango, which is allows us to use this framework. And we are also using this library to make predictions. And for the neuro headset that I'm using, we have this EmoKit, which is an open source Python library. So we were also lucky, because wherever we were looking at, we will find a solution, and it was always in Python. So we had no problem. And we also have a small rover that is kind of working. We did some tests this weekend, but it's currently not working. But I found a C++ library. I converted it to Python in a couple of hours. And now, if it works, I'm going to show you a quick demo. I'm not sure if it will work, but we can try. So this is the Neurod set I'm using. is like an emotive epoch. You can get one of these for $300. It's not really expensive. And one thing I should say is like, since we did this over the weekend, I cannot read the brainwaves yet. So this also has an accelerometer, so now I will kind of cheat and just use the accelerometer, assuming it works. But the idea is that you can also use like actually reading the brainwaves. The problem is that it takes time to convert brainwaves in some actual usable thing.
Think harder.
Yeah. So now if I can, so, okay, and I need, so just put this together like in 15 minutes. So, and I really hope it will work. Is it here? Okay, so I'll make it run. I don't know what it will happen. So,
you go on the web and search for Epoch, and you will find Epoch, or emotive.
okay, so you see something? Yeah, so now I cannot see what I'm doing because I can. Okay, so this is our simulation of Python on Mars. So I can just, with the accelerometer, I can send Python around. And you can see it's quite accurate. If I want to reach this stone here, or even this stone here, or even that stone there. So this show you like a quick demo that I put together in 15 minutes. So,
but as Ezio was saying, so
yeah.
We would like it to use for the final thing. So
yeah, so this was just like to give you like, just to have something cool to show, but this is not our final project. This is, we are actually thinking about making an actual better simulation, because since we don't have an actual rover, we have like some small prototypes. So the idea is like, we just make this one, and we make a 3D rover on a 3D landscape, like a video game, and then you can just control the rover and also train astronaut in a virtual environment. And the cool thing is that all this is software, so whoever has a PC can write it. You don't need like a lot of money to like buy like rover or build like equipment. So you just get a small initial expense for this, and then you can just write all the software you want, and the software is what will actually go on Mars. It's something that is like real, it's not a prototype. Okay, so I guess which...
I don't know, if you happen to be in Boulder, Colorado, in between the 15th and the 18th of August, there will be the Mars Society convention there, and we hope to do a much cooler demo there with Epoch using brainwaves and then a small rover going around. So if you come, you will see a nicer demo.
And I have a link? Yeah, okay. So this is the end of the talk. You can see here. And you can find more information here. Questions? Okay, we have.
Exactly saying that. For all the problem, we decided to enlighten a little the talk, so we still have 10 minutes for questions.
Yeah. Or we can also catch at lunch if you have more questions, and there's no time now. I mean, do some. Yeah? Just keep it.
Okay.
Yeah.
There we go. Thanks for the talk. It was really interesting. You've promised to share your technology with Earth, but how do we know that when you get to Mars, you aren't just going to use it to start a war with the Terrans?
Well, the technology is like open source, so everyone can use it, and yeah. So we are all on the same at the same level, so that's not a problem.
Thank you.
Something is
Really great talk, actually. A bit of a side question. Have you heard of the Mars One project?
Yes.
And what are your thoughts about it?
Okay.
We are going to approach them in few months from now and ask them to collaborate and propose to them that what we are building here become the virtual environment in which their astronaut can train to. So this is the final goal here, is being able to put together also, again, if you think that maybe you put together everything and part of it can be completely virtualized, and maybe you can have, the other step we would like to do, I don't know, is using 3D glass, for example, and integrate this technology to what we are doing here. And again, exactly the point would be, please, we do have a complete, since we cannot yet offer the physical ERAS station, we are going to offer around a virtual ERAS station that we can build without big funds, without big money, and we are going to offer it to other organizations like Mars One.
And also we are looking at like some cool gadgets like the Oculus Rift. I don't know if you ever heard of it. It's like some 3D glasses that gives you like a virtual reality experience, or even some like Google Glass. We are like kind of exploring like how these things called like if it can be used even like just for simulation, but if something similar can actually be used on Mars. So for example, the Neuro headset is something that could be integrated in the spacesuit. So you don't have to wear that, it's like integrated in the spacesuit and is reading your data. So we are also exploring this kind of like possibilities. Other questions?
Yeah, thanks for the interesting talk. I have a question on the radioactivity issue. What would you like pick up in a week on Mars when it comes to the rates in grays, and what is preventing you from using lead? Lead.
Wait. The idea is that the radiation shielding you have to create must be useful for you during the travel, and also useful for you once you are on Mars. So you have to bring it. You need to be protected while you are traveling. And this is the most important thing, because this is the most delicate time. And if you can just put together around your space capsule, for example, your water and all your waste out of your water that are protecting you. Basically, the idea here is that for this water wall, the brines generated by recycling your urine will be protecting you against radiation. So that's the idea, for example. So again, you cannot use lead just because it's too heavy, and instead, you cannot afford to bring with you something that would just do only one function, and is very heavy. That's the idea.
Yeah, you can just build a bunker on Mars, like by bringing there like loads of lead. Okay.
Hi. My question was, can you hear me now?
Yeah.
Oh, yeah. My question was about the Curiosity Mars rover.
Yes.
What you're doing, is that also collaborating with Curiosity, or?
So we are not collaborating directly, but one thing, like we were looking, because they provide some data like openly on the web. So one of the projects we were looking at was like getting this data and writing a server that we can use in our system to actually use this data and make them available. It's something that we are exploring, but as I said, there are like many possibilities, and there's just like a few people right now, so we haven't done that yet, but that's something definitely we would like to do. Okay.
Hi,
okay.
Nice talk. I was surprised that you want to use brain-computer interfaces, and I would like to ask you which software will you use to analyze the brain activity?
So right now we are kind of starting from scratch. So my next step will be like to read the raw data from the headset, and then I will see, like the idea is like writing the software myself, but I also look at some possible software. The problem is that there is some software for this headset, but you have to pay for it, and it's like quite expensive, and it's not open source. So there are, I've seen like a few alternative open source software, but there's nothing that is like, that it's like perfect for it. So it's something that I will have to look at. But the plan is like if I don't find anything that works, I will probably do it myself.
Have you had a look to buy VCI 2000?
I don't think so.
Okay, so that's a free software
Okay.
done in Python. And then second question is, why do you go for Epoch?
Just because it was like one of the cheapest one that we could found. Because
Okay.
this isn't actually. I mean, this is just like to see how feasible it is. This is not probably the final product we will use. We were just like trying out to see like how far you can get with this one. If it works, then we will invest in maybe something better, something more accurate. And but this is just what we found look like a good compromise between price and functionality.
Okay, and
You can say that if you look at the literature, there are more and more use of this device, in the sense that people, I mean, scientists especially, were skeptical about this. But if you look at more recent papers, there are papers that are coming out, scientific papers on the use of this.
because the reliability of this
Yeah.
device is not that good as another.
I know, for us it was basically the only compromise we could get. I mean, for $300 you cannot get much more, but I'm surprised myself of what you can really do with it. And sure, it's, especially at the beginning, for a single command it's very easy. You can really, I mean, with your thought, I mean, do a single command. Two, it's already, yeah. But the idea is that with some training you may be able to do something. But anyhow, with the let's say training suite that come together with the device, it's already kind of surprising what you can do.
And do you know of more groups of people that they are working with VCIs applies to Mars or like outer space experiments? Or?
The things I've seen till now, it's there are many different uses. Some of them related to the relationship with with the robots. That is very similar to what we are doing. In our case, we are focusing, let's say, rover and robots that may help you, especially because you are in a situation that is very similar to impaired people, like the classical application would be, I know, people on a wheelchair or these kind of things. While you are on Mars with the big space suite, you are similar to an impaired people. So for us, this is an interesting exploration, because we think that you need to augment as much as you can the possibility to command and drive. I also believe that we will get interesting result from the voice command. So we are trying to do it the best way we think, and the student Eric that is working on that seems the perfect guy. He has a background also on say speech and linguistics. So I think he's the best perfect person that can do these things.
Concerning weight, are you evaluating 3D printing on Mars? Just not to carry all the...
Yeah, 3D printing is also something we're exploring.
In 2 weeks we will have a 3D printer that is coming to our premises in Bergamo, and that we will be using for this kind of things, like say, sure, since I don't want to bring with me everything, and we will, this is the next big we are going to start. We need first to have our hands on the 3D printer, and then on the ERA site, the next project will be 3D printing on Mars.
Thanks.
Any more questions? Do we have time for more questions? Yeah? Yeah? Okay, last one, then we can go eat.
Hi. So trying to solve all these problems is very exciting and inspiring. But are you also, or the Mars Society, are you also working on what are you actually gonna do there that robots cannot carry out, for example, to make it worth all the travel?
Absolutely, there is really, again, if you come to the Mars Society convention in 1 month from now, you will see, I mean, how many things has been already started, how many, basically we're ready. I mean, we need the money. All the technical detail has been basically sorted. Everything you could do there, in which way you could do it, in which way you can survive there. I mean, this has been things has been studied a lot, and also the analog has been really heavily used for trying to sort out this kind of problems. So I believe that how to do things there, in which they're starting colonizing. So there are people that has already put together all the, let's say, theoretical part of in which way you can create let's say, small base there that can grow, and in which way it can be auto-sustain itself and so on. So there has been experiment in previous here. So in my opinion, we are ready, and in this moment of history, I do believe that we are nearer to a real mission than before. Think about that. I mean, the big space agency has been keep wasting money, telling us we will do that, and they do nothing. I mean, we went to the moon, then from that time we were only able to stay in lower orbit nearby with the space station. So this is amazing. I mean, come on, 40 years, you have nothing else than go back. I mean, stay nearer than before. Instead, now there are, let's say, a company like SpaceX that is putting together the hardware that could bring us there quickly, much more quickly than big space agency. There are this project of Dennis Tito that is planning a flyby and is financing the first year of the project. By the way, Dennis Tito will be in August at the Mars Society Convention. So you see, things are happening, and we hope to help a bit on, let's say, on the simulation and analog side with the Mars Society, with the little money we have available. But at the same time, it's my opinion that we are nearer to a real mission to Mars than we were 20 years ago, hoping only from the big say, space agency.
Okay. I guess we can close. No? Thank you very much. And if you have other questions, you can catch me.
That was Python of Mars. I want to